Hello, my name is Rajiv Nanchaube and I'm currently studying in International Institute of Information Technology. My project for TCS HumAIn 2019 is License Number Plate Detection and Text Recognition. In today's world, when everyone wants everything to be automated, then why not license plate detection? In this project, we will take an image of vehicles having many license plates, and then we will detect the license plate area, and then we will pass it to OCR, Object Character Recognition, to detect the license number. The dataset provided to us is in JSON format, where URL of the image is in content attribute and the coordinates of the bounding box is in annotation attribute. Here, this X and this Y corresponds to top left of the bounding box, and this X and this Y corresponds to the bottom right of the bounding box. Image width and image height is in pixels. We then change the complete JSON into CSV for easy accessibility. This is the JSON format that is present here, that we were given. This is the CSV file that I converted. Now to the implementation part. We take JSON file as an input and then we download the images using the URL present in that. We save the images in a folder. Then we change the complete JSON into a CSV file and then save it in annotations.csv that we just showed. In the data loader, we created the dataset loader part using the PyTorch dataset loader. Then here are some visualization. This is an image of car having license plate. Then this annotation bounding box is given. This is a center presenting in this cell. Now the solution part. My solution is a deep learning YOLO version 1 like CNN model, which will learn the spatial configuration within the image, and as an output it will give coordinates of the license plate. Using those coordinates, we will crop out the license plate and area to get close crop license plate. Means we will use those coordinates and we'll crop out the area which will be having the license plate. Then we'll pass the cropped image to PyTesseract, which is an IBM toolkit to extract text from an image using LSTM. The basic flowchart: we'll pass an input image of RGB to YOLO type object detector that we will be creating. Then it will give output an images coordinates having the license plate. We'll crop out the license plate, then we'll pre-process it, make it grayscale, and then we'll pass it to OCR, which in our case is PyTesseract. It will give us the text present in that license plate, which will be the license number, which in this case is KA51MJ2143. The architecture of the object detector is this. The format of output object detector. The object detector will divide the input image into 16x16 cell. Each cell will be having one object, and each cell will be responsible for detecting one object. And the output will be of 16x16x5. Each cell corresponding to the main image is one cell. Then the 5 outputs of each cell are: first, objectness score, which will represent whether the object is present in those cells or not. XC and YC represent the center of the predicted bounding box. And H and W represents the height and width of the bounding box. Training the detector. For training the detector, we will be using the ground truth. For assigning the ground truth, we will make a 16x16x5 vector, and then we will assign 1 for objectness score for the cells having center of the bounding boxes lying within them, and then we'll assign the 4 more values, which are the normalized coordinates and the true bounding box and normalized height and width of the true bounding box. Now to the implementation part. See, here we have divided the complete image into 13x16x16, and then this cell having the center bounding box's center within itself is responsible for detecting complete license plate. This is the model. This is the loss function, which is shown in this function. We will be using Adam optimizer. Then this is the part where we create the ground truth, and then we train the whole model. Then we save the weights of the trained model, and this is the plot of a loss. This is the validation loss, and this is the training loss. Now using the train detector for testing. Now to the implementation part. For the testing model, we will load the model sweat, then we will pass an input image which will give us an output of 16x16x5, and we will create we will get an image having a license plate number. We will crop out that part, then we'll pass it to OCR, which is PyTesseract in our case, and we will give the text present in it, which is KA29Z999. Thank you. That's all from my side.